So the first question on your quiz said, draw a jump discontinuity at 3. So the rest of your graph could kind of do whatever you wanted, but you had to have a jump here at 3. So I'm just going to draw something that goes like this. And you could be as fancy as you wanted with the rest of the graph, but as long as it jumped at 3. And then you had to draw in your limit statements for 3 from the left and the right and overall. All right, so this one, I'm going to ask you and just have you guys type it in the chat because today is review day. We're going over everything today. So no new information and no assignment, which is great. Today is just for review to make sure we know what's going on. So I'm going to ask you guys for the one that I just drew. What is our limit as we go to 3 from the left? What will I put for this answer? Cool. Thank you for participating. All right, 1, I realize there's a hole there, but it doesn't matter. Are we getting more used to that? Like it doesn't matter that there's a hole, just where you're headed. And then 3 from the right. So what am I going to put for that one? Sweet. All right, good. That is 3. And so if this is 1 and this is 3, the overall limit would be what? Cool. Does not exist. Sweet. All right, so that was the first one. All right, second one, you had to do an asymptote at x equals -1. And the rest of your graph could be doing whatever you wanted. So I'm just going to draw in something like this. You could have made both sides going down or both sides going up. Again, it was up to you. As long as there was an asymptote there, then you were good. So we're going to approach -1 from the left, -1 from the right, and then overall. So this one from the left, we're going to positive infinity. From the right, we're going to negative infinity. And so overall will be does not exist. And then the third one, I said to draw a hole at 5. So as long as the x value is 5, it didn't matter where you put the y value. I'm going to draw mine right here. And the rest of your graph could do whatever you wanted. And then same thing for this one. So for this one, both the left and the right are going to -2. And if the left and the right agree, then the overall limit will also be -2. So if the left and the right agree, then you just have the same answer for all 3 of those. And then number 4 had this list of basically like a scavenger hunt list of things you had to put in your graph. So the first one was limit as x goes to -infinity was 1. So that means we have to level off at 1 on the left side. And the limit as we go to positive infinity was -2. So we have to level off at -2 on the right side. So I didn't draw in anything yet. I just kind of dotted those asymptotes in so that I know where I'm going to have to level off. And then at 0, I told you the limit from the left was -infinity, and the limit from the right was positive infinity. So that means you have to have an asymptote there at 0 in order for you to be able to go up on one side and down on the other. And then last thing, the limit as x approaches 1 is 2, but the actual point at 1 was up there at 5. And I'm going to have to move this arrow over a little bit so I have a bit more space here. So I want the actual point to be up there at 5, but for the limit to be down here at 2. So we get that situation where there's that floating point that we connect to. And then I'm just going to make the rest of this level off at the asymptotes. So number 5 was explain why this graph is discontinuous at 1. And if we go through our rules, there is a point, there is a limit, both sides come to the same place, they just don't equal each other. So the limit for one of the function doesn't equal f of 1. And then the last one was explain why this graph is discontinuous at 0. And we do not have a point at 0. So f of 0 does not exist. I had some people get real fancy with that, and they wrote the limit 0 from the left doesn't equal limit 0 from the right, and that made me proud. This was sufficient. This is the easiest way to write it. That's what I would have done. But I had some people write that, and I was like very impressed. So very nice job. So any overall questions about your quiz? Okay. I'll post the answer key for it later today as well. All right, and then the second thing I was going to go over was this homework. These are limits approaching positive and negative infinity. So just to recap, if your numerator degree is smaller than your denominator, then it is automatically just going to be 0. If they are equal, then you use the coefficients. And if the numerator is bigger, then it's either going up or going down. So either positive or negative infinity, and you just check the symbols. So let's go through these. First one, who is in charge of the numerator? That would be the 4x squared. I'm going to just ignore everything else. Denominator would be the 8x squared. So since those are both x squared, that's a tie. We're going to use the coefficients 4 over 8, which would be 1/2. So for this one, in the numerator, we have 3x squared. Denominator, we have 7x to the 5th. So since the numerator is smaller than the denominator, it is automatically just going to be 0. For this one, and this was the most commonly missed one on the whole thing, so let's make sure we are careful going over this. Numerator, we have the 6x to the 7th. Denominator, we have the x squared. So numerator is bigger than denominator, so it's either going up or going down. Let's just check the signs. We're approaching negative infinity, so you have to imagine plugging in a really gigantic negative number. If you take a negative number to the 7th, it's still going to be negative. Why would it still be negative? Like, what about 7 means that that's still going to be negative? Yes, good. It is odd. So that is going to stay negative. Denominator, if you take a negative number and square it, 2 is even, that's going to be positive. So we end up with a negative over a positive, and so it is negative infinity. I had a lot of people put positive infinity. I mean, it's an easy mistake to make. Just make sure you're careful is all I'm saying. That's why I'm going over it. All right, here, numerator, we've got square root of x. Denominator, we've got -3 square root of x. They're both x to the 1/2, so that's a tie. We're going to use the coefficients. The coefficient for the numerator is 1, and the denominator is -3, so -1/3. Now these next two are using the properties that we went over for your trig, so let me just write those off to the side again just to recap. Limit as x approaches 0. Sine of x over x, that one goes to 1. But remember, you can flip that. It'll mean the same thing. And then the other one was if you have 1 minus cosine of x over x, that's going to go to 0. So looking at this one, I can rewrite it to follow this property. This is going to be limit x goes to 0, 4x over sine of x. Sine and cosecant are reciprocals of each other. So I just rewrote that as 1 over sine. And then again, this could be the other way around. So I have x over sine of x, that goes to 1, and then times 4 would be 4. And then this one, we have to factor the numerator. It's a trinomial, so it's going to split. 2 is going to split 1 and 2. Cosine squared is going to split cosine and cosine. It's exactly like splitting an x squared. It's just there's a cosine there. And to get a negative cosine in the middle, we will need a -2, and then for the outsides, a +1. And then this is over x. So this part follows our property, 1 minus cosine x over x. And if that part goes to 0, that means the whole thing is going to go to 0. And I get that factoring those is tough for you guys because you missed the last quarter of the year in pre-calc when we would have done a lot more practice with that. I can make them up all day long if you want more examples of that. When we get to going over the review today, if you're like, hey, Ms. Cole, do a few more like that, I have no problem doing that. I can do them during office hours, whatever you need, okay? And then these last two were piecewise. So this is 0 from the left, from the right, overall. So we're going to plug 0 into the piece of the function that says less than 0. And if I plug 0 in there, I'm going to get -8. 0 from the right, we're going to use this piece of the function. So if I plug 0 in there, I'm going to get 1. And if the left side is -8 and the right side is 1, they do not meet up. And so the overall limit will be does not exist. And then we're going to do the exact same thing for this one. So -2 from the left, we're going to plug into the first piece. -2 would be 2, -1 would be 1. -2 from the right, we're going to use this piece. That would be -8 plus 9, which would be 1. And if both the left and the right go to 1, that means they agree. And so your overall answer is going to be 1.